Hi grade 7s, welcome back to another one of our video lessons. So in this video lesson what I'd like to do is to go through the revision section on page 89. Guys, I get the feeling that a lot of you struggled with these fractions and when we had our Skype call. So what I want to do is I want to run through this revision. I'll do one of each and you guys make sure you do this and you get it right. Guys, if you get this wrong, I want you to try again because this is very important going forward. I need you to understand these fractions and how they work. All right, guys, so I'm going to start with the revision on page 89. So question 1, give the definitions of the following terms. Okay, guys, the definitions, you can find the definitions yourselves. They're in the keywords. If you look, they are the blue blocks in your textbook. Okay, so those you can find yourselves, and I'm sure you did that already, no problem. Right, number 2. Convert the following improper fractions into mixed numbers. What is an improper fraction? It means that the numerator is bigger than the denominator. Okay, which means that we have more slices than what we're cutting the thing into, which means that we have a whole and some fraction. So we got to break that improper fraction into a whole and a fraction portion. So let's look at that. I'll do number A, 9 over 4. Okay, there's our 9 over 4. I don't know if you can see that barely. Let me get another cue. Okay, we have 9 over 4. Right, guys, so it's quite simple to do this, right? You're basically checking how many pieces of 4 fit into 9 because that'll tell me how many whole units I have. So I know that the maximum number of 4s I can fit into 9 is 2 because that'll give me 8. I can't fit any more because then I only have 9. So the way I can write this 9 is I can say, well, that equals to 4 plus 4 plus 1, right? Then I can write this as 4 over 4 plus 4 over 4 plus 1 over 4. All right? So 4 over 4 gives me 1. 4 over 4 gives me 1. So I've got 2 whole pies or whatever you want to think about. And I have a quarter of it as well. Okay, so how do I write that? Well, that gives me 1, 1. So that's 2 whole and a quarter. Okay, so we change the improper fraction into a mixed number. Guys, I don't need you to show me these steps, how you write it out. You can do that to help you solve it. But once you figure it out, you can just give me the answer. So straight from here, you can give me that if you can figure it out. Or you can write it out like that, and then from here, you can give me the answer. Okay. All right, let's continue. Right, so that's number 2. Number 3, change the following mixed numbers into improper fractions. So now we're going the other way around. I'm giving you improper fractions, so 1 and a third. 1 and a third. Well, I'll go the long way for you. Remember, the 1 we can always write as something over something. So the same number of pieces top and bottom, which will always give you 1. So what number of pieces am I cutting things into? Thirds. So the 1 will become 3 over 3 plus I already have a third over here. So that will be a third. Well, that will equal to 3 plus 1 is 4 over 3. So I have 4 thirds. So if 3 thirds make a whole, and I still have a third, which is exactly what we started with. Okay, so the same question going backwards, guys. So 2 and 3 you should be able to get no problem. Number 4 is looking at simplify. Okay, so the idea here, remember, this 3 over 3 cancelled to give you 1 because 3 divided by 3 is 1. And we can divide top and bottom by 3. We get 1 over 1, which is still 1. So that is exactly the principle that we're going to use to cancel top and bottom because they cancel to give us 1. And 1 times anything is still that anything. So 1 times a third is a third. All right, let's continue. So they say simplify 81 over 9. Okay, 81 over 9. Well, when we say simplify, I'm asking you what can we divide top and bottom by so that this fraction becomes a simplified form? And then maybe we can do it again and again until we can't do it anymore, right? Well, from your 9 times table, you know that 81 is 9 times 9. And we're dividing by 9, so that's the common 9. So we can write 81 as 9 times 9 divided by 9. So one of these 9s cancels with that 9, so that's what I do. And I'm left over 9 over 1, which is just 9. Okay. So if you look at the next one, it's 5 over 45. Well, we know 45, 5 can go into 45. So we divide top and bottom by 5. Right, guys? So, and remember, with these examples, you don't always have to find the perfect number that divides exactly into it. So with this one, we could have said, well, we can divide top and bottom by 3. And then we would have gotten an answer. And then we say, oh, wait a second, we can do it by 3 again, which would give us the 9 cancelling, because 3 times 3 is 9. Okay. Right, so guys, let's continue. Number 5. A traditional Western pack of playing cards consists of 4 suits. So that's your diamonds, clubs, spades, and hearts. I think so. Yeah. So each suit has 13 cards. The categories of the suits in the pack are hearts, clubs, spades, and diamonds. The diamonds and the hearts are red cards, and the spades and clubs are the black cards. Each suit consists of a jack, queen, and king, which are known as face cards. An ace card has a value of 1, and the other 9 cards are numbered from 2 to 10. Okay. So guys, we're just talking about a normal deck of cards. I'm sure you all played cards and you know what it looks like. Right, it says, find what fraction of the playing cards are a red. Okay, so remember, all the cards are 1. There are 53 cards in a deck, is it? No, 52 cards. So the total is 52. We have a deck of 52 cards. That's our denominator. Out of those 52, how many are red cards? Well, they told us that 2 suits are red, 2 suits are black. In each suit, there are 12 cards. Okay, so 12 times 2 will give us 24. No, wait, it's not 12, it's 13. I'm lying. It's 13 cards in each suit. Okay, so 13 times 2 is going to give me 26. So what fraction of red cards do we have in a deck? It's going to be 26 divided by 52. Okay, I'm going to try use another marker, maybe green. Let's see if that will work. 26 over 52. Okay, that will work. Right, so that's the fraction of the red cards in the deck. Right, guys, the next 3 I want you to figure out yourselves. Okay, you got to think about it, right? Which cards are these cards? If you can't visualize it, go find yourself a pack of cards. Look at them. Find all the black ones. Count them. See if it's true what they're saying to us. All right, number 6. Complete the following equivalent fractions. Equivalent fractions is just taking half of our cake and cutting into more pieces, but the point is that we still half of the cake. So 1 over 2 is the same as 2 over 4, same as 4 over 8, and so on. Okay, so basically to find equivalent fractions, we just have to follow that process to see how does the equivalent fraction change. Okay, so let's look at an example. The first one says 2 over 3 equals something over 6. So 2 over 3 equals something over 6 equals to something over 33. Okay. Okay, guys, so the idea here is that since we have an equal sign, these fractions are all the same. So remember, to get from a 3 to a 6, we had to multiply by something. Whatever that something was, whatever we did at the bottom, we must have done at the top because our fractions are equal. Okay, that's the idea. So we're going to use that logic to find these numbers at the top. So the way we're going to do this is we're going to look at this 3 and we can see it's becoming a 6, right? What did we have to multiply by to get into a 6? So we had to times by 2 here. Whatever we did at the bottom, we have to do at the top. So it's going to be 2 times 2, which will give me 4 out of 6. We can look at this in terms of equivalent fractions, right? I have a whole pie. I've divided it into 3 parts. I want 2 of those parts. There they are. Well, here I have the same pie, and I've divided it into 6 parts, like that. Or almost like that, okay? So these should be a little bit more in. Okay, like that. So I want 4 out of the 6. So that's 1, 2, 3, and 4. It's the same amount of pi, which means it is equivalent fractions. Okay, so let's continue the same logic, right? Which one of these did I have to multiply by what to get to 33? Okay, well, I can see that this 3 looks very similar to that 33. What did we have to times 3 by? Well, 11. 3 times 11 is 33. So whatever we did at the bottom to get to 33, we had to do to the top. So 2 times 11 is going to be 22. Okay. Guys, sometimes you'll use this denominator, sometimes that one. It just depends what the numbers are. Okay. If I look at the next one, B, we have 100, 25, and 1,000. So you got to think, what did we have to do to get to each one? So to get from the 100 to 25, I had to divide by 4. If I had to divide by 4 at the bottom, I had to divide by 4 at the top. Okay. Cool, let's continue. Number 7. Replace the star with the correct relationship sign. Guys, these ones, you really have to just, in order to compare the fractions, you have to get the same denominator. We have to be talking about apples and apples, okay? So to get the same denominator, we need to convert either one of the denominators or both, okay? So let's look at 2 over 3 and 3 over 4. So we have 2 over 3 and 3 over 4. We need to convert these to the same denominator. I can't turn 3 into a 4, and I can't turn 4 into a 3. Therefore, I multiply the 2. So 3 times 4 will give me 12. So my common denominator is 12. So if I go 3 times 4 to give me 12, whatever I had to do at the bottom, I have to do at the top. So it was 3 times 4. So 2 times 4 will give me 8. So 2 over 3 is the same as 8 over 12. Now here, we want to get to 12. What did we have to multiply the 4 by? By 3. 4 times 3 will give me 12. Whatever we do at the bottom, we have to do at the top. So 3 times 3 will give me 9. Now, which one of these is bigger? Well, obviously the 9 over 12 is bigger than the 8 over 12. How can we tell? Well, we are comparing the same size slices. We've cut the whole into pieces of 12. Here I have 8, here I have 9. So definitely 3 over 4 is bigger. So to answer the question, remember they said fill the star with the correct inequality sign. We can see that 9 over 12 is bigger than that. So the crocodile eats the bigger one. There it is. Okay, there's his eye. Okay. Right, guys, so that's how you do that one. Let's continue to number 8. Calculate a 7 over 9 plus 1 over 3. Now, the same thing as with comparison or additional subtraction, we have to be able to talk about the same pieces, which means the same denominator. Alright, so let's do that. Calculate 7 over 9 plus a third. 7 over 9 plus a third. We need same denominators. Can I turn one of these into the other denominator? Yes, I can turn this 3 into a 9. How do I do that? I multiply by 3 top and bottom. So here I have 7 over 9 plus, how do we turn this 3 into a 9? We times it by 3. Whatever we do here, we do here. So it will be over 9. 1 times 3 is 3. Because 3 over 9 is 1 over 3. If we divide by 3, we get 1. Divide by 3, we get 3. So it's all legit. Now, let's continue. Now we can add these two together. So what are we going to get? 7 plus 3 is 10. Can we add them together? Yes, because we're talking about the same size pieces. Okay. Here we cannot add them together because we're cutting them into different chunks. Okay. So here we have 10 over 9. And did they say we have to give this in any form? No. So they said just calculate. I'm happy with this answer. You don't need to give me a mixed number fraction. Unless I say give your answer as a mixed number. Okay. Right, let's continue. Number 9. Guys, with number 9, it's the same thing. Convert your fractions common denominator and then subtract. Number 10, calculate. So here, same thing as number 8 and 9. Instead of calculating denominators first, we have to convert the mixed number. So it's really a combination question between the two. So we have 2.5 plus 3.75. Okay, it's just a combination question. So step 1, we need to convert this whole number into pieces. So equals, the quick way is to say 2 times 2 is 4 plus the one that I have there, which is 5 over 2. Plus 3 times 4 is 12 plus 3, 15 over 4. Right, now we have the problem of addition, but we need same size pieces. So can we turn one of the denominators into the other one for the shortcut? Yes, I can. Sorry, guys. All right, so what I was trying to say is that we can turn one of the denominators into a 4. So this 2, how do we get it into a 4? We multiply by 2. What we do at the bottom, we do at the top. So this will become over 4. 2 times 2 is 4. 5 times 2 is 10 plus 15 over 4. Right, that equals to 10 plus 15 is 25 over pieces of 4. Okay, and that's our answer. So guys, number 10 is really a combination of all the ones we've done so far, so you should be alright with that. Okay, number 11. Guys, this is a fraction question that we did in the previous exercise 6.8. Okay, we talked about fractions, and the one before that as well, 6.7. So that one I want you to try by yourself. Number 12, calculate 3/7 of 49. Guys, of is just multiplication. So 3/7 of 49. 3/7 of 49. So two things to do here. Change the of to multiplication. Change the 49 into a fraction. So put it over 1. 3 over 7 multiplied by 49 over 1. Okay, we are multiplying. We can cross things over. Okay. 7 and 49 have a 7 in common. So I divide by 7, I get a 1. Divide by 7, I get a 7. Is there anything else in common? No. 3 times 7 is 21 over 1 times 1 is 1, which is 21. Okay. So guys, with these ones, just change the multiplication and put the whole number over 1. Right, guys, number 13 is just the same thing. We're multiplying fractions. So if you did 12, you can do 13. Number 14, while banking, While baking a cake, Jill notices that 5 over 6 of a dozen, 12 eggs, is rotten. How many does she have to bake her cake with? Okay, so 5 over 6 is rotten of total of 12 eggs. How many does she have left over? So work out how many rotten eggs we have and then the subtract. 15, convert the following fractions into percentages. Okay, guys, I'll do A for you, 7 over 10. Okay, 7 over 10. Percentages are easy because percent is defined as something over 100, right? So there's a few ways to do these questions. Can we turn this 10 into 100? Yes, we multiply by 10 at the bottom, multiply by 10 at the top. So this will be 70 over 100. How do we change a fraction into percent? We multiply by 100. So this will equal to 70 over 100 multiplied by 100%, okay, which will equal to, that 100 will cancel with that, and it will leave us with 70%. Okay, guys, so revise your percentage. That's the last two exercises, 6.8 and 9. Right, calculate 50% of 34. Well, there your percentage has to change into a fraction. So remember, here we started with a fraction, then we went to percentage. Now I'm saying it's 50%. How do we go back to a fraction? Well, we just have to divide by 100. So 50% becomes 50 over 100. And then you're just going to multiply like before. Right, cool, guys. 18 is another percentage question I want you to try. So is 19 and 20. Guys, the rest are literally on the last two exercises, so I want you to give those a shot again if you haven't got them right. Guys, I really want everyone to get this revision correct. If you didn't get it all right, we need to chat about this. Drop me a text in Skype and we can look at that again. All right, guys, thank you for this lesson. We will continue with decimal fractions in the next one. All right, I'll see you later. Bye.